The purpose of this video is to clearly show the correlation between design and function. For an instrument to work well, both the instrument's design and the way they are used must be mutually supportive. The question today is whether or not the instruments that we have been taught to use as our primary shaping instruments are designed to be effective and efficient. No instrument is more familiar to us than the K-file. It is universally used whether or not one eventually switches to rotary NiTi files. Yet the K-file is criticized for excessive resistance when negotiating canals, often impacting debris, resulting in the loss of length and subsequent canal distortions when attempting to regain that lost length. Here are the reasons the K-file is poorly designed given the task asked of it. They are generally used in a watch winding or back and forth motion with some degree of apical pressure applied. Note that the cutting portion of the K-file is 16 millimeters in length with 30 flutes along its length. With such a high number of flutes concentrated into 16 millimeters of working length, the flutes have a significant horizontal orientation. When used with either a manual watch winding stroke or in a 30-degree reciprocating handpiece, the K-file is moving in a predominantly horizontal plane. As every carpenter knows, combining horizontal blades with horizontal motion leads to engagement and disengagement but does not lead to cutting. This is the proper design for a screw, whose purpose is to engage and hold two parts together, but it is not the purpose of an instrument designed to shape canals. If one then looks at the orientation of the 16 flutes on the working length of a relieved Reamer, you will note that the flutes are approximately twice as vertically oriented. The fewer number of flutes leads to less engagement and a more flexible instrument, further enhanced by the flat incorporated along the length of the Reamer's entire working length. Most importantly, when the horizontal motion of the flutes is applied to the walls of the canal, the vertically oriented flutes immediately cut dentin rather than engaging and disengaging. Understanding this most basic of concepts is critical in understanding if the instruments you are being asked to use are rational in design and function. Knowing what we know now, we can state categorically that the flutes on another reciprocating system are designed wrongly. Note the flute's horizontal orientation. These flutes will engage and disengage but not cut nearly as effectively and efficiently as the more vertically oriented flutes of a relieved Reamer. Another interesting observation is to note the vertical orientation of the flutes along the length of a rotary NiTi file. In fact, the NiTi instrument has the design of a Reamer, not a file. If it was consistent with the misplaced design of a K-file, it would simply screw into the tooth and almost immediately break. The fact that the NiTi file is really designed as a Reamer should give us ample evidence to support the use of relieved Reamers over the universal but irrational use of K-files. Please note that the flute design on a relieved Reamer is similar to that on the rotary NiTi instruments. They both have vertically oriented flutes. To drive home the point about compatibility between design and function, we know that all the instruments will be driven manually, or engine-driven by either a rotating or reciprocating motor, all of which are predominantly horizontal in application. It should be very clear by now that horizontal flutes defeat horizontal motion, while vertically oriented flutes enhance horizontal motion. Please note that the vertical flute orientation provides a series of cutting blades along length that, combined with the two vertical columns of chisels, that remove dentin in both the clockwise and counterclockwise direction. Another significant observation is the snapback property of NiTi. This is not an advantage because it tends to selectively shape canals to the outer wall. Compare this snapback to the recording of a curve when a deforming pressure is applied to stainless steel. One might think that an instrument recording a curve would distort the apical preparation of a canal. However, as this video clearly shows, once the tip of the instrument is confined by a solid object, the tip of the instrument becomes a point contact with the arcing of the instrument transported more coronally, helping to shape the canals to a greater diameter exactly as desired. Point contact around curved canals is enhanced via the use of the reciprocating handpiece. No matter how I apply force to the instrument in the canal, the point contact remains stable. nor does the tip of the instrument create its own canal because the forward motion is limited to 30 degrees, preventing the embedment into solid tooth structure. As you can see, the problem with rotary motion is it allows an instrument with a cutting tip to quite rapidly create its own pathway with minimal pressure applied. This is not what we want from a rotary system that is supposed to be protective of the canal anatomy in the apical third. This video covers the most basic areas of design and application we must know to make intelligent decisions on what to use. The good news is that the principles are easy to understand and apply. Vertically oriented flutes are a plus. Horizontally oriented flutes are a negative. The recording of a shape is good. Snapback is bad. Reciprocation provides an added measure of safety when it comes to cutting tips and keeping instruments intact. If you absorb these simple points, you will be well on the way to making better endodontic decisions.